find the absolute and local maximum minimum values of f of x equals x squared minus 2x minus 3. 0 less than equal to x less than equal to 3. Begin by sketching his graph line. Okay, so first off, a little vocabulary for you. First of all, absolute maximum and minimum. And then you have the local maximum and minimum. All right. Absolute maximum and minimum would be the absolutely highest and lowest value on the graph. Okay, there's nothing higher, there's nothing lower. All right. So if I was just drawing a picture real quick, if this is my graph, that's the absolute maximum. Because it's the highest point on the graph, nothing's higher. All right. If the graph looks like this, this is a maximum value in its area, but there's higher values over here. This is the lowest value in its area, but there's lower values over here. This is a local maximum, and this is a local minimum. All right? So that's what it means. In the sense of one like this, where you have a specific domain given to you, we only care about values from x equals 0 up to 3. That's all we want to graph. Then there's going to be a highest point and a lowest point on the graph because there's not going to be an arrow going forever. So the lowest point might be here, it might come up to highest point here and come back down to maybe there or something. I don't know. I can graph it to see. So it does say to begin by sketching this graph by hand. This is just old-fashioned graphing. We pick x based on whatever rule there is for x. If there's no rule, we can pick anything we want to. In this case, the rule is right here. X must be between 0 and 3. Anytime you have a interval that you're going to be graphing, then the numbers on the ends have to be picked even if there's not an equals to. If there was just less thans, then you would have put open circles there. Since there's equals to, though, we're going to put closed circles. So 0 and 3 have to be picked. As far as picking other numbers, 1 and 2 seem friendly. And the fact that we're graphing a quadratic function, we have some idea based on experience with quadratic functions from Algebra 2 and Geotrig, where we can find the vertex value is going to be negative b over 2a. That gets me positive 1, which we've already decided to pick. So that would be a number I'd want to pick. All right. If that was 2/3 or something else, I'd obviously want to pick that number. Okay. Hopefully it lies within our region. As far as finding y is concerned, y is simply what this equals when we substitute these x values in. So if we put 0 in, 0 minus 0 minus 3 is negative 3. 9 minus 6 is 3 minus 3 is 0. 1 minus 2 is negative 1 minus 3 is negative 4. 4 minus 4 is 0 minus 3 is negative 3. If you're not as comfortable evaluating things in your head like that, again, they were just integer values raised to powers and multiplying them. It wasn't terribly difficult math. Fine. If you feel less comfortable with that, then by all means type that in your calculator y1, go to your table, enter those values in, and it will result in the same y's. So as far as graphing is concerned, we're only graphing on this interval here. Maybe I want to use a little scale. I've got a pretty decent sized piece of graph paper here. 1, 2, 3 spaces over is only that much. So maybe I'm going to make x at a point. Let's go at a 0.5 scale. I can't quite fit a 0.25 scale on there. So a 0.5 scale on the x-axis. As far as y is concerned, it goes up as high as 0, goes down as low as negative 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like we've got a 0.5 scale on that also. If you choose to scale anything, scale everything. So maybe I'll go 0.5 here and a 1 there. Just let me know what the dashes represent on your paper so when I'm looking at your graph I can make heads and tails of what you did. So 0, negative 3, so 0, 0.51, 0.52, 0.53 would be right here. Again, I'm using a closed circle because that does say equals. 3, 0, 0.51, 0.52, 0.530 would be right about there. 1, negative 4, 0.51. There's negative 3, 0.5, negative 4. And then finally, there's 1, 1.52. And we've got to go down to negative 3, which we've already established is right there. And just like that, I get a very easy parabola graph to look at. So if I've already graphed this thing and I want to identify the absolute and local maximum minimum values of this function, I can just look at the picture and see these numbers, these values, okay? The lowest point on the graph is right there. Its coordinates are 1, negative 4. And when it's asking for the absolute and local maximum minimum values, they want to know the y values and where they occur. All right? So the way we write our answer is absolute minimum of negative 4 at x equals 1. That's how you write an answer to a question like this. And again, that's using the graph in order to answer the question. All right? Tell me what the value is, the y value, and where it occurs, the x value. Looking also at the graph, this is the highest point on the graph. The highest point occurs right there. That's the absolute maximum value of 0 occurs when x equals 3. So absolute maximum of 0 at x equals 3. Okay, now continuing to look at the rest of this thing, all these points are getting lower, 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 lower to get here. Then all of a sudden it starts going higher, higher, higher until we get here. This is the highest value in its area. Okay? Again, there's higher values on the graph, but this in its area, there's nothing higher than that point anywhere around it. Okay, that's a local maximum. So I'm going to say local maximum of negative 3, there we go, at x equals 0. Now let me throw a little what if at you real quick, because this is going to happen in your homework, and I want you to know how to handle it when it does. Suppose, okay, there's our interval, right? And we have the equals to, so we have the closed circles on those zeros, right? 0 and 3. All right, suppose that they did this. It didn't have the equals to. We just said less than. Let's see how that would modify anything. So instead of the interval, instead of the domain they give me this domain instead, which again, the only difference is there's no equals to. The difference in your graph would be this is an open circle, this is going to be an open circle, right? So on my graph, instead of having a closed circle here and here, I'm going to have an open circle here and an open circle here. All right? Those open circles mean they don't exist. That's our boundary, but we're not including that in our boundary. So I see this would be the highest point, but it doesn't exist, right? So the highest point doesn't exist, therefore there is no absolute maximum value.
You wouldn't make it just like the 1 or
the 2.9999999 comma negative 0.000001. How many 9s and 1 zeros do you want to put in? You see, that's the question.
Oh.
There's no maximum because you continually get closer to that point without actually hitting it. All right. So again, if no point exists at the highest value, there's no absolute maximum. Same deal over here. This is the highest point in this area, but it doesn't exist. There's no local maximum either. Okay, so when that occurs, when you get a situation where the graph ends at an open circle at a spot that doesn't exist, even though it would be the highest point, it doesn't exist, it doesn't count. All right, so that's how you handle that scenario if that happens, which again will happen on the homework. So, and again, that's using nothing but your eyes and Algebra 2 skills right there. Didn't use any calculus in there. Okay, there's calculus we can do to make this happen also, but I want you to see how to do it. Algebra technique first, before we do any calculus technique.